Okay, so let's walk through the derivative of inverse functions. And what this allows us to do is find the derivative of inverse functions that when we can't just like find the function. So you know that to find inverses, you can switch x and y and solve for y, but it's not always possible to do that algebraically. So this allows us to take the derivative of any inverse function without having to actually find what the inverse function is. So recall some information about inverses. If f and g are inverses, then the input for g is the output for f. Okay, so the input and the output switch. That's why when you solve algebraically, you switch the x and the y. You're switching the inputs and the outputs, which also means if the output, which also means the output for g is the input for f. So we're switching the outputs and the inputs. So if 2 is an input for g, then 2 is an output for f. And if 2 is an output for g, then 2 is an input for f. The graphs of g and f reflect over the line y equals x. Okay, so remember if you have like a square root function, right? Then the inverse will reflect over that and look like this because it reflects over the line y equals x. If f of 1 is equal to 4, so that means you have the point 1, 4, then what point is on the inverse graph? Well, since the output becomes the input and the input becomes the output, the point 4, comma 1 is on the graph of f inverse. So if 1, 4 is on the graph of f, then 4, 1 is on the graph of its inverse. Again, because we're reflecting over the line y equals x. So let's find a rule for the derivatives of inverses. So if f inverse is equal to g, so we're saying that f and g are inverses, then what does f of g of x equal? So think about like if I have sine and sine inverse, okay? What if I take sine of sine inverse of x? Well, the point of inverses is that they undo each other, right? And what are you left with? You're left with the input, which is x. So the point of inverses is that they undo each other. Another example would be like ln of e to the x. ln and e are inverses. So when you use composition, you plug one into the other. Again, we're not multiplying, we're plugging one into the other. They cancel and you're just left with x. So f of g of x is equal to x. And remember, this is how you showed when you're in Algebra 1, like you were proving, or even last year in pre-calc, you prove that two functions are inverses by plugging one into the other and showing that they undo each other and you just get x. Okay, so let's differentiate both sides using the chain rule. So the derivative of x is just 1. The derivative of f of g of x using the chain rule is the derivative of the inside, g prime, times the derivative of the outside with the inside still plugged in. Okay. And then because we're finding the derivative of g, we're finding the derivative of the inverse, then g prime is equal to 1 over f prime of g of x. So this is the rule for the derivative of inverses, 1 over f prime of g of x, where g is the inverse of f. Okay, so another way to write this is 1 over f prime of f inverse of x. We don't usually like to write it this way because it's kind of confusing. Like you have like the inverse here and then you have the derivative here. They are two different things and they kind of look really similar. So we try not to write it like this, but you could. But the idea is if f and g are inverses, then the derivative of g is 1 over f prime of g. Okay, so you're using function composition within a derivative here. So let g equal f inverse, then g prime is equal to 1 over f prime of g of x. Okay, so that's the rule. This is what you want to memorize. Okay, or be able to set it up this way and then just remember your two steps. Take the derivative using chain rule and then divide. All right, so now we are going to do an example here. So use the formula for the derivatives of inverses to find g prime of 1 if f is equal to tangent. And then we're going to verify using our formula for the derivative of arctan. So we already know what the result should be because we have our derivative of inverse trig functions memorized using the like s stands for square root and subtract and the t looks like a plus sign, all of that stuff. So what we're going to do now is like show that that's true even with this formula. So we're going to find g prime of 1. So g prime of 1 would equal 1 over f prime of g of 1. Okay, well, f is equal to tan inverse. I'm sorry, f is equal to tan. So what I want to show you is 1 is the input for g, right? So if 1 is the input for g, then 1 is the output. I'll even write this down. 1 equals input for g, then 1 is the output for f. Okay, so what I'm going to solve here using my function is 1 is equal to tangent of x. Okay, so 1 is equal to tangent of x. Okay, well, where does tangent equal 1 on the unit circle? And you should know that that is pi over 4. Okay, so you don't have to actually, I'm not taking tan inverse of both sides. Instead of 1 being the input, since 1 is the input for g, 1 is also the output for f. So you can plug in this number as the output for the original function. Because again, that's the relationship with inverses. Input becomes output becomes input. So if you have an input value, just make it the output of the original function. Okay, I know this part's confusing for people, so just make sure you understand. The input is 1 for g, then 1 is the output for f, and just set f equal to 1 and then solve. Then that gives me g prime of 1 is equal to 1 over f prime of, and then our result was pi over 4. So now f is equal to tangent, so f prime is equal to SST secant squared. So what is f prime of pi over 4? Secant squared of pi over 4. Okay, so secant squared is the same thing as 1 over cosine squared. Or you can just flip. So cosine of pi over 4 is root 2 over 2 squared. So this is 1 over, and then root 2 squared is 2. 2 squared is 4. 1 over 2 over 4 is the same thing as 4 over 2, which is 2. Oh, wait, I circled that. I'm sorry. That's just what f prime of pi over 4 is. I still need to plug it back into my formula. So my answer is 1/2. Okay, so again, you need to solve by using the input as the output for f. The input for the inverse is the output for the original, and then solve. And then it's 1 over f prime of that value. So I found f prime, and I got 2. And so then my result using the formula is 1 over 2. Now we are going to verify using the derivative of arctan. So we know that the derivative of arctan is 1 over x squared plus 1. Because a tan looks like a t looks like a plus sign, remember? And then it's 1 and x squared. Okay, so the derivative of arctan at x equals 1 is just going to be 1 over 1 plus 1, which is 1 over 2. So it checks out. Okay. So in this case, I was able to check. You will not always be able to do that. In fact, you often will not be able to check your answer. But again, the input becomes the output for the original. And then you do 1 over f prime of that number. 1 over f prime of that number. And don't forget the 1 over part. I almost forgot it, which would be bad. But it's 1 over that, the f prime of that.